All right, we are jumping into the next lesson, which is 10.4. The name of the lesson is going to be ratios of areas and perimeters. Rather than just going over and giving you guys the punchline and saying, memorize this, I want you actually to develop the theorem, basically. So what I did was I gave you a situation, and if you can figure out the situation, then you have developed the skill that you're going to be using for this section, which is ratios of areas and perimeters. So the start thinking part says, you start a lawn care and maintenance business and you get your first client. You are paid to mow his lawn and paint his fence. He pays you separately. You're paid $30 to mow the lawn and paid $50 to paint the fence. You do such a good job that he hires you to do the same thing for his rental house. But the lawn has the dimensions that are twice as big. So it's similar, geometrically speaking, but just twice as big as the owner's property. How much should you charge him for mowing, and how much should you charge for painting the fence? You must be able to justify your answer. And then once you're done with that, go over and think about how much would you charge for 3 times the dimensions. So that we're all on the same page, let's start with the same figure, and then I'll turn you guys loose. Let's pretend like here is the original one. The original property is going to be a 1 by 3. So this figure has a certain perimeter, and this figure has a certain area. What I want you to do is investigate using the little boxes, knowing for the first one, it's that big, and then the new property, all the dimensions, the length and the width will be twice as big. Right off the bat, what does your brain say? If I say the dimensions are twice as big, how much should you charge the person? Yes, twice as much. Sounds like a great deal. You'd get really grumpy once you started mowing and realized that you should have paid attention in your geometry class, because that's not right. What I want you guys to do is experiment here by going over and drawing figures that are twice as big, 3 times as big, 4 times as big, meaning the dimensions, and try to figure out what the rule is. What happens to the perimeter as you get bigger, and what happens to the area. People who are at home, I'm going to pause the video. You think about it too. All right, people in class, you should have found that given this figure right here, the perimeter was what, 8? And the area was 3? Okay, what was the perimeter of the next one? 16. What was the area? 12. And then this one, the perimeter was 24, I think. And the area was 27. Okay, so we have to look at this and try to figure out what is going on. When you went over and doubled the side length, what happened? We'll do perimeter on top, and then I'll do area on bottom. When you doubled the side length, what happened to the perimeter? It just doubled. Good. When you tripled the side length, what happened to the perimeter? It just tripled. Okay, so it seems like the rule is whatever happens to the side also happens to the perimeter. Does anybody have any questions on that? Okay, the next one. When you go over and you doubled the side length, what happened to the area? It became how much bigger? 4 times as big. Okay, next one. When you went over and did 3 times as big for the side length, what happened to the area? It became 9 times. So we have to figure out what the rule is here. It seems like the rule for perimeter is easy. The rule is whatever you did to the side is what you do to the perimeter. Now, what is the rule for area? When you doubled the side, it became 4 times as big. When you tripled the side, it became 9 times as big. Take a guess. When it is 4 times as big for the side, how much is the area going to increase by? What's it going to be? 16 times as big. Okay, and if it was 5 times the length on the sides, then the area becomes how much bigger? 25. So it seems like you just take this number and do what to it? Square it. That is basically the rule. So we have to figure this out. Once again, so you went over and you were the property was twice as big. So this mowing the lawn is like area. Twice as big, right here, twice as big, actually made the area how much is big? Four times as big. So if you charged $30 originally, how much should you charge for mowing now? $30 originally, how much would you charge? $120. 4 times as much. 120 bucks. Does anybody have any questions on that? Next, the fence. The fencing, you originally charged $50, and now the property is twice as big. How much should you charge? What happens when you double the side length? You double the perimeter. So it is going to be $100. Does anybody have any questions on that? So let's go ahead and put that all together into a theorem. Here is basically what the theorem says. If you know the ratio of the sides, if the sides is A to B, for example, doubling would be 1 to 2, tripling would be 1 to 3, quadrupling would be 1 to 4. Whatever the ratio of sides is, the perimeters are going to be what? If it was side is A to B, what is the ratio of perimeters? No. Didn't we say whatever happened to the side was exactly what happened to the perimeter? So that must mean that the ratio of perimeters is also A to B. But what about areas? If the ratio of sides was A to B, what did we have to do to our numbers when we were looking at the areas? Square them. So it's not A, it's A squared, and it's not B, it's B squared. So if you know the sides, it will be exactly the same thing as the perimeters. If you know the perimeters or the sides, you have to square it to find the ratio of the areas. Now going the opposite direction, what about if they gave you the ratio of the areas and you wanted to know sides? Instead of squaring, what would you do? Square root. Does anybody have any questions on that? So let's go ahead and do a problem really quickly. You can already see here that the ratio of sides is 6 to 9 or 9 to 6. I'm going to call it 6 to 9. And just so that we don't end up with enormous numbers afterwards, I'm just going to reduce. It's 2 to 3. So this is the ratio of sides. If the ratio of sides is 2 to 3, then what is the ratio of perimeters? 2 to 3 as well. Yeah, it's the same exact thing. That's not necessarily saying that the side length is 2 and the side length is 3, but just when you reduce it, it becomes 2 to 3. It's not saying the perimeter is 2 and the other one's 3. It's saying when you reduce it, it becomes 2 over 3. Next, what is the ratio of areas? Is it also 2 to 3? No. What do we have to do to the ratio? Squaring. You are squaring it, not square rooting, squaring. That gives you 4 to 9. Does anybody have any questions on that? We're going to skip this problem because we have applications actually at the end. Let's see if you guys actually know what you're doing. Here is a chart. It either gives you the sides, the perimeters, or the areas, and it wants you to find the other ones. So give this a shot. When you have problems like this, you can reduce your fraction. So on here, you can always math frac it. Feel free to math frac. That means put it in your calculator, press enter, press math frac, and it'll reduce the fraction for you. People at home, go ahead, pause the video, and fill in this table. All right, you guys should have had, for the first one, you would have had 5 to 8. So therefore, this one is also 5 to 8. This is knowing something's happened to my drawing pad. And this one would be 25 to 64. Does anybody have any questions on that? This over here would be 4 to 7 as well. And this one would be 4 to 7. That one's 16 to 49. Tracers. It's weird. Okay, when you square root both of those, you get 13 to 6. And this one would also be 13 to 6. Hopefully this doesn't keep doing that. What does this reduce to? 11 over 11 to 3? Okay, so it's 11 to 3. And then it is going to be what? 121 to 9. Does anybody have any questions on that? All right, let me show you how this is going to work then. What's going to happen is they're going to give you a ratio. You'll have both of the numbers. You might be able to use that ratio, or you might need to adapt that ratio. So for example, on number 1, you have both of the numbers for what? The sides. But we are solving for a what? An area. So when you go over and write the ratio, 5 to 12, can we use that ratio if we're going to solve for an area, or do I have to adjust it? Adjust it. So we can't use this. What do we have to do to this one so that we can use it? Square it and square it. And that gives you 25 over 144. And now the smaller one had an area of 50, so I can put a 50 here. and I don't know the other area. So the original ratio that we got of 5/12 is not the ratio we're going to use. We actually had to adjust it. If they gave us sides and we are going to perimeters, we wouldn't have had to adjust it. But since we're going to areas, we do. Cross multiply, sum with the calculator. What is 50 times 144? 7,200 equals 25x. And when you solve, you get x equals what? 288 inches. Is that answer reasonable? Yeah, it's bigger. Does anybody have any questions on that one? Let's look at the next one. They gave us the ratio of what? Areas. 18 to 98 is the ratio of areas. I am solving for a side though. Do I keep the ratio or do I have to adjust it? You got to adjust it. But the only thing here is, are those numbers nicely square rootable? No. So first things first, before you do square root, see if you can reduce that and see if it becomes something nice. It may or may not. What do you guys end up getting when you do 18/98 math bracket? 9/49. Those are both nice numbers. So we'd be able to square root it, and that gives us 3/7. That's the ratio we can actually use. So 3/7 equals 4/x. And you get 3x equals 28. So x equals what? 9.3 about inches. The most important thing here is to know that when you get your original ratio, you may or may not be able to use it. Most times you will not be able to use it. You're going to have to adjust it. Let's do one more, and then we'll get to the application problems. So looking at this one right here, what did they give us the ratio of? Areas. It's 21 to 37. They want the ratio of what? We're solving for a side. Okay, so we're going to have to square root these. Are they nicely square rootable as is? No. Okay, they're not nicely square rootable as is. If we math bracket, does it do anything? No. So that just means leave it as is. Just call it square root of 21, square root of 37. And now we have the ratio we want. So we can say equals 5/x. And you just treat it like it was a normal number. Rad 21x equals 5 rad 37. Now, when you solve this, I highly recommend, unless you know how to use parentheses really well, put this in your calculator and press enter, and then do your division. Divide by that. Do it in 2 different pieces, and that kind of takes away the need for the parentheses. If you say 5 rad 37 divided by rad 21, it gives you a different answer because it or the other kids were getting a different answer. It still seems like you should get the same answer, but for some reason people weren't. You get 6.6 or 6.3 or what? 6.6. Is that answer reasonable? 6.6 inches is because the bottom one had a bigger area, so B obviously has to have a bigger side. Anybody have any questions on how I did that? No? Okay, you're going to practice in the homework. Let's go to the applications to make sure you understand the applications. The reason applications are hard is because they don't just say, hey, you're solving for the area, or hey, you're solving for the perimeter. You actually have to think through the problem and ask yourself, what did they give me and what am I solving for? So this says you have a wall. Here is the wall. It has a base of 12. It costs $75 to paint that wall. Then they have another wall that is similar to it, geometrically speaking, but the bottom is now going to be 20. And obviously the height grew as well because it becomes a similar figure. They want to know, how much money does this cost? So we have to go through a process. What is the ratio they gave us? Ratio of sides, perimeters, or areas? Sides. So the sides is 12/20, and I'm going to reduce that to 3/5. That is the ratio of sides. Now here is where the thinking comes in. When they tell you how much it cost, you need to figure out, does that cost have to do with the perimeter of the figure, or does that cost have to do with the area? Check with your neighbor, see if you guys agree with what that is. What is that going to be? All right, what'd you guys get? Painting the wall. Painting the wall, is that area or perimeter? Area. So what do we have to do to our ratio? We have to square it. So we get 9/25 is the ratio we can actually use. What if they said baseboards? Do you guys know what baseboards are? Would that be perimeter or would that be area? Baseboards are the things at the bottom of the wall. That would have been perimeter. So the ratio we had would have worked. But since we're doing painting on a wall and that's area, it's not. So that's going to equal 75 over x. We better get a number bigger than 75. So when you cross multiply and you get 9x equals, I don't know, what is that number? 75 times 25? 1075. 1875? Okay, 1875. And when you divide by 9, what do you end up getting? Is that a reasonable answer? 208.33. That's your final answer. Does anybody have any questions about why I went over and adjusted my ratio or how I did? Okay, we only have 3 minutes left. Let's go ahead and do this one. Hey, by the way, this problem makes no sense whatsoever. It says 16 acres is inside of something that only needs 10 or 100 feet of fencing. An acre, I believe, is like 144,000 square feet. So this problem doesn't make sense if you actually worked it out, but let's just run with the numbers. You can still do it. It just doesn't make sense. So here, they tell you a 16-acre piece of property requires 100 feet of fencing. A similar piece, geometrically speaking, has an area of 9 acres. How much fencing does it need? So what is the ratio they gave us? Sides, perimeters, or areas? Areas. So you get an area of ratio of 16 to 9. That's areas. Are we going to be solving for a side or a perimeter? I mean, does it matter? No, because we still have to do the same thing to the ratio. What do we do to ratios of areas to get sides? Square root, square root. So the ratio that's actually going to help us is 4 to 3. And that equals 100 feet of fencing. I don't know how much fencing. So you get 4x equals 300. And when you solve this, we ask if our answer is reasonable. What do you guys end up getting? 75 feet of fencing. Is that reasonable for our problem? It is. Yeah, you got a question?
Well, okay, so I kind of like solved this the same way, but for the last problem, I just did like times 3.
Number 1 or number 2 problem?
This one, but I also did it for the first one as well. I just did what 4 equals 100 times 25.
So yes, you can do that if it's like you could say times this instead of cross multiplying. You mean? Yeah, you can do that if it's easy. But think about this: if it was 4 over 3 equals 127 over x, what is 4 multiplied by to get 127? I don't know. So that would be. But yeah, that's a little shortcut. All right. Does anybody have any questions on this? Make sure you don't just by default use the ratio they gave you. You might have to adjust it. All right. That's it. Thanks a bunch for watching.